So let's get started. Today we will continue with more advanced stuff about plotting. We will cover changing colors, adding error bars, adding text, changing the themes, some tips and tricks, and a final exercise. From our last session, we made a basic plot like this. And today we're going to look at how we can modify the template. For example, if you want to change the colors, if you want to modify the text size, the font family, also you want to remove borders, you want to remove the background color and all, and so on and so forth. Also adding text. And we'll go through all of it today. So if you have not already done so, please open the workshop project. It's going to take a while. So while we are loading, just some couple more information. In the handout, you'll see that there are a few PDF files. We have the book that I used to base this workshop upon. It's free on the internet. It's done in it's built on with R. So this is it's built on LaTeX and R. So these are all the examples you can follow. For more details, you want to look at even more specific exercises, example tutorials over here. So they have a lot of chapters. And also the themes, which I will show you later on. And most importantly, it is the cheat sheet for ggplot. So if you go to rstudio.com, there are a lot of cheat sheets for R, and ggplot is one of them. So these are examples you can follow, different types of jumps like we talked about on Tuesday. And for different types of plots, for example, 2 variables, single variable, 3 variable plots, they have some recommendations for you for different types of data. For example, if you look at time series, you can look at geom area, geom line, so on. For more of the engineering stuff, you can look at geom bin, depending on what kind of analysis you're looking at, what kind of plots you want to make. And also more about stats, building layers, like you want to create density, counts, creating different kinds of statistics like box plots, so on, quantiles, quartiles, and so on. All right, so let's get back to here. Once you are here, we are at the main directory. Go to handouts, click on handouts, click on 02-advanced ggplot.rmd. So RMD stands for R Markdown, which I already have opened it here. So we're not going to need this document right now because it's going to take a while. And we already have a knitted document prepared for you. So same as 2 days ago on Tuesday, there's an FOI, best practice, and also a puzzle for you, exercise for you to complete, and also a note, which is a hint for you to use during the exercise. And also, there are more packages that we need to use today. So if you have not need to document for getting started, it's okay, it's fine. We will do it here in this example. So once you're okay, once you're ready to go, click on the arrow button on the right to load the package for this workshop, and also the packages that we need specifically for today. Okay, once we have loaded our packages, we are going to load our data. So let's load our data on the right. Click run current chunk. So we have loaded the full data, and we have filter 7 different types of Pokemon. But today we are going to use the entire data set. So we're going to use the whole 1028 Pokemons today instead of 529 we did on Tuesday. So we have, from our Tuesday's workshop, we have added colors to our plots, but sometimes it is not the color you want. Sometimes for publications, there are specific requirements. Maybe your university or maybe your lab wants specific colors for you to emphasize. Maybe there are certain requirements, like I said. So in that case, we need to change the colors of our plot. So to do that, we have to remember or to identify where we change our color. Did we use aesthetics fill or aesthetics color? So this will determine what code and where we will change our color. So let's use our weight bar chart as an example over here. So we create a bar chart, summarize the data for the mean, create a ggplot, create the x and y axis, and then add geom bar, set the color for fill. Remember that for bar chart, we use fill instead of color because color is for the borders. Additionally, we add borders, set it as black color border. And then we add some labels for XY title and the legend. This is for the legend. And then you can see that we have a lot of different colors here for all these 18 types of Pokemon. So you can see the colors are kind of in a continuous format from red to pink and going to blue, orange, everything going there. So this is not really a discrete color, but more of continuous color. And we might want to change the color because some colors are very close to each other, so we cannot identify the Pokemon or the types of Pokemon. So one thing to note, that we use fill equals type 1. So this is where our target is, fill. Now, we want to change the color here. So we have 18 types of Pokemon, so we need 18 different colors. So to change the color manually, we can use scale fill manual. So if you are using color equals type 1, then we use scale color manual. And we can set different colors for different types of different levels of the factor. So here we see 18 different types. So here I've already set 18 different types of colors for each Pokemon type. And there are random colors here, which is essentially the same as Poké colors, but the difference is we are not attaching a name to that color. So there's a difference here. Let me show you. So over here, this is the first one with Poké colors. You can see that each Pokemon has a specific color to the standard Pokemon color for that Pokemon type. So for Bug, it's a little bit olive. Dark type Pokemon, it's a little bit brownish green. For Dragon, purple. Electric, yellow, just like the Pokemon type. And Water, blue. But for the second one with random colors, even though you see that the arrangement is the same as the first one, now the colors are a little bit different. This is because when we use the first one, we are tagging the type of Pokemon to a specific color. Without that, we are only labeling each color by the order of appearance. So you can see here, it is by order of appearance from alphabetical order. So from A to Z. But with the first one, we are ordering it by the type of Pokemon with specific colors. So if the color matters to a specific level of factors, then you might want to pass a label to the color like we did over here above in Poké colors. If you just want a different color, you can just use random colors and just fit a different set of colors here. the code for scaling colors is scale underscore the aesthetics and then underscore manual or something. There are also different types of scale or different types of themes you could use. There are also predefined colors, like for example, brewer set. There's a brewer color palette for set 2. But it is important to know that for some set of colors, they do not have 18 colors. Some of them only have up to 8 or 10 colors. So it's also uncommon to have more than 10 different levels or factors. So it's also important to note or to be mindful if you expect people who may be colorblind who are going to read your graphs. So if that's the case, you might want to search for more colorblind friendly colors. So we're going to spend the next 5 minutes to create a speed bar chart over legendary status. So this is a bar chart. And create a labels for X, Y, title, and fill. And change your legendary status to these 4 colors. And name this plot as GG speed bar. All right, so let's review the exercise. So what we need to do first is to create to summarize the score, because we need to, it's a bar chart, so we need to summarize. So we need to group by status, and then summarize, what's it called, speed. Speed equals mean speed, and then type it again, ggplot x equals, aesthetics, x equals status, y equals speed, plus, and then geom bar, and then position equals dodge, stat equals identity, and then 8. And then after that, we need to add the aesthetics for color. So fill, remember it's fill, not color. Fill equals to status. And then we add labels. And then we add. So this is the architecture or the skeleton of the plot. So X will be the legendary status. So just to review what we did on first Tuesday, and Y will be the speed. Title, we just say speed of Pokemon by legendary status. And do we need the fill? We don't need the fill. We don't need the fill because it's self-explanatory. So one thing we're still missing is the legendary color. So we need to put legendary color first, which is equals to this. Use C for combine, bracket, put those colors in, and then add quotations for each of them. Remove the N, and then add another one for here, just to make sure everything is there. All right, and we can, last thing, we need to call gg.speedbar. And then plot it. So we're just reviewing what we did on Tuesday, and additionally, we are changing the colors here. So you can see now there are 4 different colors for each legendary status and for speed on the speed bar. So that is how we can change the colors of our plot. Any questions so far? Okay. So right now, there are several statistics you may want to add to a plot, but today we are going to focus on error bars. So error bars inform us about the variation in our data. We can add standard deviations or we can add standard errors depending on the type of discipline you're in, type of field, type of the requirements, and so on. So we can use mean, median, SD for means, medians, and standard deviation, but there is no function for standard error. So you will have to compute one on your own by creating a function. And then you can use it the same way you use median, SD, or mean. But today we will not focus on SE or standard error. We're going to focus on standard deviations. So we made a variable or an object with summarizing it with mean. We can also do the same with standard deviation like this. So right now, in addition to summarize attack mean equals mean, we also did median and SD. So over here you can see the attack, mean attack, median attack, and the standard deviation for attack. If you want, you can also create one for a standard error. So now we have created a df.attack data frame for attack the summarized data. We can use that data to create a plot for to add geom, the error bar. So we're going to create the standard geom bar coordinate flip. Yes, we're going to add using geom error bar to a template plot we create right now. And for error bar, we need to put in the minimum. So that's the lower bar, lower quartile, and lower end, and then the max for the higher whiskers. So lower and the upper whiskers. So I've also added coordinate flip because the one we have over here in the first one, we cannot see all the Pokemon type. So I've just flipped the coordinates so that we are able to see each Pokemon type. So right now you can see that we've created a bar chart with the standard deviation or error bars over here. So that's how we create a plot with error bar. There are also lots of different variations of error bars you can create. Ones with just lines, no whiskers, so just lines. And also a crossbar, which it's not my favorite. It's not my favorite because the colors are very similar and you can't really tell where the error bars are or the mean, even though you can see it's a darker line, but it's still not very pleasant looking. There's also point range, which has a dot or point on the mean and then the lines. So we can also plot half of the error bars by specifying mean or the max or the minimum as the mean. So we just remove the top or the bottom, the lower or the upper parts. So over here we do want a mean. We do want a minimum. So we set it as the mean. So it will not go beyond or below the mean. But if you see carefully, you can still see the lower whiskers here. The reason for that is because of the layering of ggplot that we talked about on Tuesday. So to account for that, we could either plot the error bar first and then plot the geom bar after that, or we could set the whiskers for the lower part to be 0, which I will show you later on. So over here, as we plot the error bar first and then the geom bar, so the error bar is now at the underlying layer, and then we map the bar on top of the error bar. So right now you can see that the bottom whiskers is now being overlaid by the bar. And now you can see the errors more clearly than before. So like I said, the other way is to add the border to your bars or to set the whiskers to 0. But we're going to add a border. So for border, remember, use color equals to black. And now you can see that it looks much neater, even though the error bar is now overlaid on top of the bar plot. So I want you to try for 5 minutes to create a summary data for speed over legendary status. So this is what we have already. But right now, please include the SD and also the mean, and create a bar chart and add error bars or line range. So something for you to try out. Add width equals to 0 to see what the output looks like. Okay, let's continue with the exercise. So let's create a summary for speed over legendary status, group by legendary status. So over here, we need to add speed underscore SD equals to SD speed. So it's one thing you have to note, you cannot rename it as speed, because if you rename it as speed, the entire line will get updated, and then right now there is no standard deviation because you only have one value for each status, so that it's only the mean scores, so you cannot find a variation with the mean score only for it. So you only have four values. So here we need to rename it as mean or something else. And then let's call it df.speed. So after that, we can create a bar chart, ggplot, AES, x equals status, y equals speed underscore mean. And then we add jump bar. That's gonna copy. Jump bar, everything's the same. So we only need to change attack to speed. So what else do we need to do? Add error bars on line range. Okay, we've done that. So let's try width equals to 0. I'm going to add minus speed SD. So we have the full whiskers. And I'm going to add width equals to 0 outside the aesthetics. So to show you what the width stands for. So if you have not already tried, you can do that. So I'm not going to scale colors and not going to add labels. And I'm not going to flip the coordinates. So with width equals to 0, you can see that we've taken out the whiskers. So if you set width to, let's say, 5, you can see it's gonna look very strange. So the width stands for the whiskers on the top and the bottom. So let's put 0.5 or 0. Let's just keep it to 0. Okay, let's just also add fill equals to status. Okay. So now we have the speed bar, speed status, legendary status bar with similar as the line plot. Okay, there's a question. So object speed mean is not found after typing a code. So let's take a look at it right now. Okay. So I'm gonna set as an example. Okay. Okay, speed mean. So let's see. Over here we have Okay, my speed is showing. GG speed, DF speed, jump crossbar. Oh, so here you see the error here is because here it's GG speed, but you have not created a GG speed yet, if I'm correct. Unless you're using GG speed from before, which is from here. From before, let's see. But that's so far back. Over here, you need to create a new object. Where's my? Let me go to speed. So over here, you need to create a new bar chart here using your current DF. So which is your DF speed. And then you have to plot status speed mean. And it should show up by now. So, okay, I'm going to use your example here to add crossbar and labels. So you shouldn't use the GG speed I created because it's an old object that we created. So you have to use the new one. There you go. You have the crossbar here, and you can see that. Let's see. Speed mean speed SD. Yeah, it looks correct. Yeah, only that the colors are different because you need to add aesthetics to jump crossbar also. Okay. So let's carry on to adding text. So we can also add text to plots, which will be very useful if you want to show the mean on the bars or to point at certain positions in your scatter plot. So there are two ways to do that. One is by jump text or jump label. So jump label draws a rectangle behind the text, making it easier to read with a background color, while jump text just plot text. So both of them taking the same aesthetics as any other jumps. You can put in X, Y, color, fill, etc. But for the text to show, you need to supply it with labels equals to some value, where the label argument is where you want the text to show. So for example, let's see what I did here is to add the jump, same thing, summarize the generation 1 to 8. We have 8 generations of Pokemon. Summarize the attack median, the attack for the means, median, standard deviations for the attack. Create a ggplot for those values, or yes, those values or variables. Fill with factor. So you could do that here, or you could do that in jump bar. And then for jump text, we have the Y axis. So remember to leave some gap because the Y argument stands for the Y coordinates where you want the text to be displayed. So if you put it on attack underscore main, it's going to show on the bar itself. So we want to leave a few space on top so it shows above the bar. And then for label, we can create a mean score for, if you want to show the mean score or the mean attack for each generation of Pokemon, we can do that. Round it so we can create the labels using mean attack. So you can see 77, 72. So we've created the labels or the labels for each generation of Pokemon. So let's spend 5 minutes to try this exercise to create a summary data for speed over legendary status. Use the same one previously. We have done this too. We have done this as well. So only thing you might want to do is to add add text over the error bars using jump text or jump label. So you can try both. And if you're using error bar, please also add the SD on top of 5 so that you have enough space to account for the standard deviation. Okay, let's start. Okay, so let's take a look at the exercise. So let's bring the speed plot that we created over here. We just need the df speed. Just copy df speed and see what else we need to change. Create a summary data for speed over legendary status. Yes, we did. Yes. Create a speed bar over legendary status. Yes, we did. And add error bars or line range. Yes, we did. And add text over the error bars. Okay, so let's try with jump label. Okay, jump label. What else? Or jump text. So hint, use jump text to set y coordinates above the error bars. So this is the attack. We need to change it to speed. So speed mean plus speed SD plus 5. Okay, what else do we need? We need to add the labels. So labels equals, see if I just correct label, not labels. Okay, so you want to add the speed. So this will give us a very long string of numbers because we are not rounding off. See, you can see we're not rounding off here. So if you want to round off, we can add round to round off, and then comma to how many decimal places. So we want to round off to 2 decimal places. So we put 2. Round speed label. It's the error, incomplete expression. Okay, incomplete expression. Yeah, one more parenthesis. So right now we have the mean of mean over legendary status. So let's add a little bit more space. There we go. So a little bit more space. So you can see it's different from the jump text, because jump text, you can see above, you just put it only has the text, but with jump label you have the colors. And additionally, if you want, you can also fill equals to status. So like before, you can add other aesthetics to it, and then it's going to fill by the different colors. Okay, so just put this in chat. So here you can see, you can also remove this later on, as we will do it later. Now this is the more interesting part, or the more exciting part, the more artistic part of the workshop, which is setting the theme. So we can set themes for adjusting non-data properties of the plot, such as the titles, like changing text type, text size, font family, yes, font properties, axis and legend placements and titles, background colors, guideline placements, and like there's all the ticks and the lines, grid lines, and all that. We can change all that in themes. So there are lots of themes we can use. There's also a documentation for you to take a look, and they have examples also. But essentially, there are also available themes you can use, which I'll show an example here for different type of themes. Okay, just give it a moment while it loads. So we have black white, which looks like this. We have gray theme, which is a default. Minimal with no boxes, with no XY, and it's white and black. Theme void is just a plot, no access at all, no labels, no titles. Classic theme with no grid lines and so on until theme light. So these are default themes you can use, but if you do not like them, you can create your own as well. So this is a weight bar, which we did earlier on. And you can see how it looks with theme minimal. So here you can see there are some things we still need to fix. The title is meaningless. It's meaningless, it's very self-explanatory. Overlapping axis labels, so we can't see the Pokemon type. We've seen it earlier, how we can use coordinates flip, but I'll explain to you in more detail later. Legend has no meaning. There's no point putting it because it's Pokemon, it's already inside the x-axis itself. And if you don't like grid lines like me, you want to remove them. And I don't like the default fonts, not a fan of that, so I want to change that as well. So let's go item by item. So title is meaningless. It's fairly simple to fix by setting let title equals to a blank, just space. And then if you run it, you can see that now we do not have a title anymore. So item 1 done. So number 2, we need to change the axis, rotate the axis. So we can use that by adding coordinate flip to our text or plot. So Cartesian coordinates and x and y flip. So it's going to flip the x and y axis. So there are also other coordinate systems, functions such as polar to create polar plots, flip map for creating maps, Cartesian for cutting x and y axis, fixed for creating fixed axis, and so on. So you can take a quick look at all of them at your free time later on. So next item, we want to remove the legend. So to do that, we have to use the theme. And inside theme, we have to add legend position equals to none. So legend position tells ggplot where you want the legend to be set. Could be left, top, bottom, so on, and so forth. So if you set it to none, we will not see the legend anymore. So no more legend, because there's no point putting a legend for each Pokemon type. It's a waste of space, doesn't add any value to the plot, since we already have all of them here. So next one is to remove grid lines. Over here, I do not like grid lines. So if you're the same, we can remove that. There are several options: panel grid lines, major and minor. Major grid lines are for the ticks over here, 200, 150, 150. And minor grid lines are for those in between. So these options pertain to major and minor grid lines. So to modify them, we need to set the elements to element underscore line. So the properties of element underscore can be found in documentation. So to remove the grid, we can simply use element underscore blank. And if you want to set specific grid lines for the major or X grid lines, you can use it element underscore line. So for points, there are different types of elements we can use. So if you look at theme in the documentation, there is a huge set of different themes. And you can take a look at what are the options and so on, and see what the element underscore line, what are the other options inside lines. So essentially, for blank, we create a blank score, not blank score, a blank element. So we remove all elements. For rectangle, it's for borders and backgrounds, to modify borders and backgrounds. Element underscore lines to modify lines. Element text is to modify text, for example, the X, Y labels, titles, and so on. Okay. Yes, so next one, you want to change the font. So there are also many options for axis text and axis title. This is for the title. The text is for those ticks, those labels. So what we did here, we have modified the grid lines early on. Now we want to change the labels. So we can change or change the size, change the family, change to bold, italics, and so on. So right now you can see that this is a mono font family, just like in Pokemon Game Boy, the same type of font. So right now you can also see the thick major grid lines is solid and the minor grid lines are dotted. So this is one way to modify the theme of a plot. So let's spend about 5 minutes here with your speed bar. Remove the title. It doesn't have information. Remove the legend. Modify the grid lines in any way you want. And set the font size of the x-axis to 22 and y-axis to 18. Set the font family for the axis to mono. So for your hint, you can use axis text equals element text or axis titles, so to set both x and y axis. All right, let's go through the exercise. So, okay. Do we have a gg.speed bar? gg.speed. Yes, we have a gg.speed bar here. So remove the title, class labs. Okay. Labs, sorry, it's title equals empty. Remove the legend, class theme. Forgot what legend stands for. Legend position equals to none. Let's just copy this thing here. Legend equals to none. Okay, modify grid lines in any way you want. Let's set to 2. For minor grid lines, let me put blank. Okay, minor horizontal grid lines. Let me put blank as well. Axis labels, we want the X. Let me just copy here. Okay, so for the x-axis, we want the overall font size for x-axis to be 22 dot x dot y to 18. Change the grid line from x to y since we didn't flip it. Right. Okay. Okay, so we can change the font size, set the overall font family for the axis to mono. Yeah, we did that here, axis title. And then let's plot it. And hope there is no error. Okay. Okay, so you can see, let me just stretch this a little bit. Looks big, but that's how it is. Yeah, so that's one way to create the plot. So to change the axis. So over here, there are still some stuff I want to change. The major grid lines blank instead. So it takes a while to tweak the graph in the way that you want. Oops. Parent function, I have to start changing device. Okay. All right, so there's something wrong. Okay, I might not have the bandwidth to do that, so I'm just going to change the font size back. Okay, that's strange, but function file name. So sometimes maybe that I don't have enough memory space to plot the graph, so that's one of the reasons why this thing occur. But anyway, here's the output. So we are almost near the end. So I just want to share some tips and tricks before we move on to our final exercises. So we can also merge different plots together by creating 4 different plots in one plot. So to do that, we can use ggarrange. So ggarrange comes from the ggplot package, it stands for publication ready. There are also other packages for you to explore. I have put down all the resources below and also in the homepage. So for example, if I wish to create this 4 different plots in one single plot, and one thing you might notice is there is this attack is the common denominator across all 4 plots. So first we can create a sample plot and then turn it into a function so that we just need to use the function to create all these 4 plots. It is fine if you do not know how to create a function. I will share with you one by one. So we create a function here, not a function, create a plot here. All right, I don't think I am able to. This is strange, so I might have to restart this. All right, so we can create a speed bar, a sample bar. Let's wait for it to load. Okay, so over here, what I did is I created a smooth first and then plot the points. So you can do the opposite, but I'm going to do it this way. And then add the labels, set the theme to black, white. You can set any theme you want and modify everything as if this is the final plot that you want to create. So once that is done, so let's say this is the final plot. My normal type Pokemons are gray color. And then once we have that, the only one thing we want to take note of is the things that we want to change are the X, the Y. Everything else should stay the same because we are only changing the X variable and Y variable. So these are the parts of the plot that we want to extract out and make an argument out of it, or an argument. So what we do is create a function, we set the data, we set the X and Y variable, X title, Y title. Everything else is the same. We can just copy from before, take the mutate. This is the same. So over here, I'm using jump jitter. So the points do not overlay. This is the same as jump point, but with jitter, you're jittering the points so they do not overstack 100% on each other. Everything else stays the same. One thing that's different here is I'm using AES underscore string instead of AES. The reason is because AES takes the value as the argument. So if you put ASD, it's going to look for the ASD variable itself rather than the string that's the variable is named ASD. So that's why we use string instead if you're using it inside a function. So after that, we set it as a function. And then we can use that function to create different plots for different variations of the same plot. And then we put that all into one plot. Now you can see that we've created attack versus defense versus hit points, catch rate, and speed in one single plot. 4 plots in one single plot. So this is an example of how if you want to merge different plots together, let's say because they are related, you want to make a same point in two different plots, but they carry the same meaning over those two plots. So that's one way to do it. So right now we're going to spend the next 8 minutes for the final exercise, the ggplot league. So we've been through most of the basic and some advanced plotting techniques. It's time to put everything together. So you can be creative here with your plots and showcase your personality, your creativity with the plots here. So we're going to spend 8 minutes. We're going to use the same one, GG. It's the same. So use your speed bar, remove the title, remove legend, modify grid lines. You can try to be more creative. You can even try to explore more options with the themes, change the colors if you want. And some hints, you access text, access title element text for overall settings. So let's spend 8 minutes here. So actually we're out of time, so let's spend 5 minutes. Okay, so let's go through the exercise. So geom speed bar, I have added the color black, so to create a black color border. Also, I've changed it to sans, to serif, so Times New Roman, make the size a little bit smaller. So there's still more things you could do with this, but this is just an example. So now you can spend more time to create your own theme, or to create plots, or just set a different color. So this is just an example here. Okay. So yes, so last thing of all today, second last thing actually, is sometimes you might want to emphasize a certain point in your graph, a certain aspect of the graph, because that's the highlight of the graph. So maybe there are a lot of things to unpack in one graph, but you want to highlight certain points. So we can do that with ggplot as well. So over here, for example, we can plot height versus weight for Pokemon. At one glance, you can see there isn't anything special except some outlying points over here. But if you look carefully, these outlying points have special meaning, and there's a reason for that. So there's an unusual pattern. So we can add add a label. So there's another package called in ggplot called geom label repel. It's the same as geom label, but it's more sophisticated. You can add box paddings, can point paddings, and more functions here. You can also subset data, same as other geom objects. So here I'm going to subset a data, generation 1 Pokemon only. So I'm going to filter only generation 1 Pokemon. Geom point, so something new here is PCH. So this is the point colors. You can see the colors of the points is, now we can change the colors of the point. You can add borders to the point using PCH. And then I'm going to subset the data to create a specific labels for some points. So I want to create a subset, a group which has weight more than 200 kg and height less more than 6. So these are the tall and heavy Pokemon. And after that, we have the heavy but short Pokemon. And then we have the light but tall Pokemon. So we have one set here, and one set here. So 3 different subsets. So after that, we can see that these different Pokemon who are outlying Pokemon make sense. You can see Gyarados, Mega Gyarados, Onix, they are large Pokemon. They are long. So height is fairly taller than other Pokemon, but because they are Onix, and Onix is a rock type Pokemon, so it's very heavy. Gyarados is also heavy, it's a dragon type Pokemon. A lowland executor, it's tall and heavy. It's a giant tree, coconut tree. Snorlax golems are short but heavy, so you can see. Dragonair is very light, can float, I think. So it's light, but it's tall. Arbok also, and Weezing. So Weezing is a floating type Pokemon, so it doesn't really weigh that much. So you can see these are the different groups. So by identifying this Pokemon, now the focus is on this Pokemon rather than entire graph. So if you're looking at the outliers instead of the entire trend, this is one way to do it. And we can further highlight these Pokemon using GG highlight. Check the documentation over here. I don't think they have it here, but you can check the documentation for more details. So we're going to highlight this Pokemon using a different color. So what it does here, it's going to highlight only this Pokemon, while the rest of the Pokemon will be gray in color. Also, I'm going to change the color to Verity's color to make it more explicit, so it's more obvious with the speed. So we're looking at speed of Pokemon for the different points. So now we can see what are the traits of this Pokemon that make them more unique than other Pokemon in the 150 the first 150 Pokemons. So this is also the first graph that you see in the handout that was given to you, and also in the slides. So finally, there are also other domain-specific plots we can do. For example, polar plots using coordinate polar to look at different properties of the same type of Pokemon over different statistics, like attack, defense, hit points, special attack, special defense, and speed. So there are other ways to use polar plots depending on your field of research or discipline. So this is an example. We can also create heat maps to look at relationships among different variables. It is also an excellent tool for visualizing the different events within data set to highlight what matters the most in that data. So over here, we have the damage taken of different types of Pokemon against all the other Pokemon types. So for example, bug type Pokemon, where if they are fighting against fire type or flying type, they are taking 2 times damage as compared to when fairy type Pokemon, when they are fighting against dragon type Pokemon, they are taking 0 damage. So this is a little bit complicated to view, but there is also another way to view this kind of plot, which is via network plot, which I'm just going to show you how it looks like. Since we are actually out of time. Okay, I'm going to put the colors. Okay. And now when we plot this network, we can look at the different relationships between how much damage they take, how much damage they are going to put out. So over here, I highlighted those who are Pokemons that will do double damage and receive more damage. So you can see the relationship between all different types of Pokemon. So grass type Pokemon are the worst. There are more Pokemon that are effective against grass type Pokemon than it is against other type Pokemon. Same for dragon, although there is only very little Pokemon that is effective against dragon. You can see fighting type Pokemon are effective against more Pokemon than Pokemon that are effective against fighting type Pokemon. So also you can see that the size of the circle or the nodes depend on how much effectiveness it is against other Pokemon and how much damage it receives against other Pokemon. So the higher or the larger the circle or the node size, the more effective it is against other Pokemon, like fighting type Pokemon. So this is just an example. We can also create volcano plots or maps, geographical plots. There are also a lot of different maps you can use to download, to create plots. If that's something you're interested in, or if that's in your field of research, we can create this type of plots and to plot the distribution of volcanoes across the planet. Okay, so that is the end of today's workshop. So over here, I've put up some resources. Some takeaways for today is customizing the colors, adding error bars, text, and customizing themes, emphasizing our data. So if you have finished this, you can also knit the document. So to create a HTML document, a completed document. So if you have any questions, please email me or put it in chat. I'll be here for another 5 minutes.